Hello everyone, myself Mrs. A Doddi, Assistant Professor in Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's lecture, we are going to study about the survey lines and its classification. At the end of this session, the students will able to define the bearing of the survey line. The students will able to explain the different types of the bearings and their uses, and the student should able to calculate the included angles of the given bearing system. The bearing of a survey line is the horizontal angle made by the survey line with respect to any reference direction. The bearing is used to represent the direction of one of point to the another point. In this figure, the survey line P makes the 48-degree angle with the north direction. So, we can say the bearing of the survey line is 48 degree. Here, we will consider the bearing of the each survey line with respect to the north direction in whole circle bearing system. Here, these are the two types of the bearings, that is true bearing and magnetic bearing. True bearing means it is the inclination made with the true meridian. True meridian means it is the geometric north and south direction which will pass through the center of the earth. So, the bearing which will measured with the reference to the true meridian are called as the true bearings. And again, if you can observe, it is called as magnetic meridian, means we are using the prismatic compass to measure the bearing of survey line. So, it will use on the surface of the earth. So, the magnetic bearings are the bearings which will measured with respect to the magnetic meridians. Now, we will see what is fore bearing and back bearing. Here in this figure, it is shown the survey line AB shown with the angle theta, and here the angle beta at station A and station B with respect to the north direction. When we will measure the bearing from the line from the station A to B, it is called as the fore bearing of the line AB. So, when we will start from the station A to the station B, it is called as the fore bearing of line AB. And for the same survey line, when we will measure the bearing from the second station to the first station. So, for in this figure, if we measure the bearing from station B to the station A, it is called as the back bearing of survey line AB. So, the fore bearing is measured in the upward direction from the station A to B, and the back bearing is measured in the downward direction from B to C. In simple words, fore bearing is the bearing measured in first point to the last point, and back bearing is the bearing of the same survey line, but it is from the last point to the first point. Here it is shown that the relation between the fore bearing and back bearing. So, the difference of fore bearing and back bearing should be always equal to 180. So, it is called as your bearing or your survey line is free from any local attraction. If the fore bearing is less than 180 degree, we can calculate the back bearing, that is 180 degree plus fore bearing. If the fore bearing is greater than 180 degree, so we can calculate back bearing, that is fore bearing minus 180 degree. So, at last we should get the difference between the fore bearing and back bearing should be equal to 180 degree. Now, we will see what is meant by included angle. So, here included angle means these are the internal angles which will made by the two survey lines. So, here you can observe in this figure 5, that is the survey line AB, survey line BC, survey line CD and survey line DE and E are considered in the sequence of the bearings. So, this angle A, angle B, angle C, angle D and angle E are called as the included angles, or we can call it as the interior angles of the given bearing system. Okay. So, the interior angle should be less than 180 degree. But some cases the interior angle should be greater than 180 degree. So if you observe this figure 5, here you will get all the included angles should be less than 180 degree. But if you observe this figure number 6, at this angle D, the included angle, that is the interior angle D, is greater than 180 degree. So in some cases the included angle should be greater than 180 degree, but normally those should be less than 180 degree. Now we will see how to find out the included angle. So here in this question they have asked to find out the included angles of given bearing system. So line PQ is having the fore bearing of 41 degree 20 minutes. So it is less than 90 degree. So here it is shown P2Q, that a fore bearing is 41.20 degree. Then fore bearing of line QR, it is 114 degree 30 minutes. It is less than 180 degree. So it will lie in a second quadrant. So here the fore bearing of line QR is 114 degree 30 minutes. Similarly for line RS, it is 164 degree 40 minutes. So again it will lie in a second quadrant. So the fore bearing of RS is 164 degree 40 minutes, and the fore bearing of line ST, sorry, it should be SP, it is 275 degree 30 minutes. So the fore bearing of line SP is 275 degree 30 minutes. So whenever you are plotting the bearings, it should be a closed bearing system. So here it is, we can observe closed bearing system. Now we will see how to calculate the included angles. So the included angle P is calculated as back bearing of line SP minus back bearing of line PQ. So here you can see included angle means this internal angle P. This internal angle P. So we know the back bearing of line PS and the fore bearing of line PQ. So if I subtract the fore bearing of line PQ from the back bearing of line SP, so we will get this internal angle. So here if I subtract this 41 degree 20 minutes from the 94 degree 30 minutes, that is back bearing of line SP, so I will get the internal angle P. Similarly here for the included angle Q, if I subtract the fore bearing of line QR from the back bearing of the line PQ, back bearing of the line PQ is 221 degree 20 minutes and the fore bearing of line QR is 114 degree 30 minutes. So if I subtract this 114 degree 30 minutes from the 221 degree 20 minutes, so I will get this included angle Q. Similarly here for included angle R, if I subtract the fore bearing of line RS from the back bearing of line QR, I will get this internal angle R, because both the fore bearing and back bearing are measured with respect to the north direction itself, at station P, at station Q, at station R, as well as at station S. Now for the included angle S, I will do the same procedure, that is the back bearing of line RS minus fore bearing of line SP, we will get the included angle S. So it is shown here all the included angles, how to calculate. Now pause the video and try to find out the included angles of this given bearing system. These are the answers. Now we will see what is meant by whole circle bearing. Whole circle bearing means the bearing of each survey line should be measured with respect to only the north direction and in clockwise direction only. So it is called as the whole circle bearing system, because here we will consider 0 to 360 degree of the bearing. So in this, the each bearing should be measured from the north direction and in clockwise direction only. The next one is quadrantal bearing system. Quadrantal means here we will consider only the north and south direction to measure the bearing of survey lines. It is also called as reduced bearing system. So we can measure the bearing of survey line with respect to the nearest south direction or the nearest north direction. Now we will see how to convert the whole circle bearing to the reduced bearing. In this first figure, this survey line P will make. Now we will see how to convert the whole circle bearing to the reduced bearing. So in this first figure, survey line P having the bearing of 132 degrees. So if I convert it into the reduced bearing, so I can convert like this, that is reduced bearing is equal to 180 degree minus 132 degree. So we will get 48 degree angle. So we can call like the survey line P having the bearing as 48 degree E, means it is acting 48 degree from the south east. So it is called as the reduced bearing of the survey line P. Likewise, we can convert the whole circle bearing to the reduced bearing. Then how to convert the reduced bearing to the whole circle bearing? So here this survey line is making 48 degree angle with respect to the south direction. So it is less than, so if we in here in this figure, the survey line is making 48 degree angle with respect to the south direction. So if I want to convert it into the whole circle bearing, so we have to measure from the respective north direction. So here from the north to south it is 180. So if I subtract this 48 degree from the 180 degree, I will get the whole circle bearing of this survey line. So here the whole circle bearing is equal to 180 degree minus 48 degree. We will get it is 132 degree, which is from the respective north direction. So likewise we can convert the whole circle bearing to the reduced bearing as well as the reduced bearing to the whole circle bearing system. So these are the various references considered in the study. Thank you.